Hello students, today we're going to be taking a look at section 1-4, solving absolute value equations. Absolute value expressions. So the absolute value of a number is its distance from 0 on a number line. The symbol absolute value of x is used to represent the absolute value of a number x. So as you can see kind of written here in blue and off to the right there on the number line, if I were to ask you for the absolute value of -2 or the absolute value of +2, in both instances the result is 2. And the reason is because technically on the number line what you're being asked to find is the distance in units that -2 and 0 are from each other, but also the distance that +2 and 0 are from each other. So that distance of course being 2 between 0 and -2, and 2 between 0 and 2. So that's really what the absolute value entails in terms of the symbology, but also in terms of the number line. The absolute value in words for any real number a, if a is positive or 0, the absolute value of a is a. If it is negative, the absolute value of a is the opposite of a, as we just discussed here. As far as the symbols go, for any real number a, the absolute value of a is a if a is greater than or equal to 0, and the absolute value of a is equal to -a if a is initially less than 0. This looks a little bit different, but think of what would happen if a started off being negative. So the absolute value of -2 is equal to negative of -2. So in the end, negative of a negative, of course, ends up being positive. Notationally, it is a little bit different looking, but we know that it is true in this particular example, like we said earlier, and based on the number line to help guide us. Example 1. Evaluate the absolute value of -4 minus the absolute value of -2x if x equals 6. So what we're going to go ahead and do is substitute 6 right in for x, and that gets us started where if now in the next step you see the absolute value of -4 still left unsimplified, but now minus the absolute value of -12. This carries down quite nicely, so this, of course, the absolute value of that becomes 4, and then that, the absolute value of -12, 12. So 4 minus 12, easy enough, -8. Example 2. Evaluate the absolute value of 2x minus 3y if x equals -4 and y equals 3. So from here, what we're going to go ahead and do is substitute again, knowing that we have x and y. So the absolute value of 2 times -4 minus 3 times 3. Of course, this is nice, -8. This is also nice, -9 or -9, you could say. That ends up being -17. And then, of course, the absolute value of that ends up being +17. I'm going to go ahead and move on. There are a grouping of select questions that I wanted to take a look at. For problems 1 through 24, you're given w is -4, x is 2, y is 1/2, and z is -6. So let's do number 1. The absolute value of what? 2 times 2, and then -8. They had absolute value. We've got 4 minus 8. Of course, the absolute value then of what? -4 simply is +4. Number 2. Absolute value of 6 plus z minus the absolute value of -7. When you plug in -6, you get 6 plus -6. Of course, that ends up being 0. The absolute value of that simply is 0. Minus the absolute value of -7. Be careful, the absolute value of -7 is +7. That minus sign still has to be attributed, so that what? 0 minus 7 yields -7 for your final answer. Number 5, the absolute value of x minus the absolute value of y minus the absolute value of z. So absolute value of 2 minus absolute value of 1/2 minus absolute value of -6, or 2 minus 1/2 minus 6. I got a common denominator here. Okay, as you can tell, technically I did 2 minus 6 first. 2 minus 6 is -4, but because the 2 has to be the same in both denominators, this one isn't obviously starting off as that. So I multiplied this by 2 over 2. So technically this ends up being -8/2 minus 1/2. -8/2 minus 1/2 ends up being -9/2. The 3 problems there that I've highlighted in blue, I'm going to do one of them with you, and I'd like you to try one on your own and cross-check to see that your work matches my work and answer. I'm going to go ahead and discuss number 8. So the absolute value of what? W times Z, so -4 times -6. Be careful, minus, I'm going to apply that in a moment, the absolute value of 2 times a half, or X times Y. This ends up being what? Positive 24. When you take the absolute value, of course, still positive 24. Still minus, and then what? 2 times a half, that's 1, the absolute value of which is still 1. 24 minus 1, easy enough, 23. So I'd like you to try 10 and 12 on your own. You can pause the video and cross-check to see that you're on track. Moving on to the next page, as you can see here, we're going to go ahead and work with absolute value equations, but solving in particular. Solving these. The absolute value equations use the definition of absolute value to solve equations containing absolute value expressions. It does say for any real numbers a and b, where b is greater than or equal to 0. If the absolute value of a equals b, then a equals b or a equals negative b. And here's a great example, a quick example to highlight, such that if you were given this equation not knowing x, how do you go about solving something like this? Well, if the absolute value of x equals 2, there has to be two choices, right, or two solutions, and really choices to consider, right? So 2, of course, makes sense. The absolute value of 2 we know to be positive 2. But also, -2 must also work, because the absolute value of -2 is also 2. So in both cases, you're highlighting the fact that not only does a equal b as a solution, a equals -b as a solution. We always will need to check our answers by substituting them into the original equation, and sometimes, as you'll see, computed solutions are not actual solutions. So in some cases, even after checking, it doesn't work. So you do need to check your answers. Example, solve the absolute value of 2x minus 3 equals 17, and we're going to check our solutions. So case 1, when a equals b, we set 2x minus 3 equal to 17. If we add 3 to both sides of the equation, here it's going to cancel on the left side nicely. So therefore 2x equals 17 plus 3, so 20. Divide by 2, and boom, x equals 10. To check our solution, that's a simple matter of literally plugging in 10 into the expression here. So 2 times 10 minus 3, that absolute value. And the next step, it continues, of course, the absolute value of 17 equals 17, so the answer checks. In other words, 10 is a good solution. Case 2, 2x minus 3 equals -17. Okay, we'll go ahead and do the same basic process of solving for x. Add 3 to both sides. On this side it cancels. On the other side you'll do the math to get -14. Divide by 2. X equals -7. Okay, let's check our answer on this one too. So what? 2 times -7 minus 3. Take that absolute value. In other words, -14 minus 3, which is -17. Find that absolute value, and boom, 17, of course, checks out because it equals the other side. Because they both work, we can argue that two solutions are in fact our final solutions, so 10 and -7. Moving on. So like the previous page, there's a variety of good questions that I wanted to highlight. We'll jump right in and looking at number 1. I will do some others and maybe have you guys try some on your own, similar to the prior page. Possibly. We'll see. So the problem at hand, number 1, the absolute value of x plus 15 equals 37. We're going to solve it, of course, but remember, check your solutions. So the first equation, x plus 15 equals positive 37. That's easy enough to solve. Subtract 15, x equals 22. The other equation, x plus 15 equals -37. Subtract 15. Notice the sign is negative as opposed to positive from the case 1 instance. Case 2, this is negative. If you subtract 15, you get -52. So to check our answer, I'm going to be kind of quicker on this particular question, and I'm going to do this by the following. I'm going to use, as you can see here, I'm going to use the calculator feature where if you were to hit the math button and then go to numbers, you have the ability to type in the absolute value. Okay. Now for our purposes on this particular problem, I'm going to go ahead and type in 22 plus 15 and take the absolute value, which shouldn't be a big surprise. Of course, it's 37. And then I'm also going to do negative 52 plus 15. And you can actually hit, second, enter, and you can go back and type in over whatever you want. In any case, negative second insert of 5, so that boom, of course, you get the same exact result. So that's a nice quick way to check your answer. I'm going to show you another way on the calculator to check your answer, which is just as effective. Number 2, the absolute value of t minus 4 minus 5 equals 0. First step, add 5 to both sides. Because once you do this, you're getting it to where you have an absolute value isolated on one side, which is ideal to then say, well, one equation, case 1, t minus 4 equals 5. Case 2, t minus 4 equals negative 5. Easy enough, add 4 to get 9, add 4 to get negative 1. So for this problem, what I'm going to actually do, I'm going to use the calculator again to check my answer. This one will be a little bit simpler to check. I'm going to take, in both cases here, I'm going to take my value, in this case 9, store 9 as x. Now when you store a number as x, or any variable for that matter in your calculator, it's now stored for all intents and purposes whenever you want to use x in any context. So let's go ahead and do that with t minus 4 minus 5. Remember, you're doing the absolute value. So math, numbers, absolute value, t or x, I'm going to use x, minus 4, and then minus 5. Okay, so that was the original problem. We better get 0 as a result, and of course we do. Because we're just going to use x again, but now restore it as negative 1. For various problems, you're going to want to do this if there's way more, let's say, steps involved. So if I restore now negative 1 as x, hit second enter a couple times, second enter twice, or you can just scroll up. If you have the same calculator that I do, you can scroll up and hit enter there. Some of us have a TI-83 Plus and not this exact calculator. Nonetheless, if you do it this way, you better get the same result as we see, 0. So true, this is true that these two answers are in fact solutions. Number 5 is a great example of a problem where possibly there isn't a solution. And you do need to check your answers as evidence here in a moment. Absolute value of 5b plus 9 plus 16 equals 2. Subtract 16 from both sides. When you do this, again, you're isolating the absolute value. Now, as we think about, though, how this is going to play out in advance of actually doing the algebra, if you ever take the absolute value, I'll point to this, if you ever take the absolute value of any quantity, we talked way back at the beginning of our lesson that it always ends up being a positive result. So there is no number that you could ever plug in here for b and get a negative answer. So the answer will end up being no solution, but let's prove it using the two cases. So 5b plus 9 equals negative 14. In other words, you take the original problem and leave it. But also 5b plus 9 equals positive 14. You take this sign and you take its opposite. Subtract 9, divide by 5, so you get negative 23/5. Do the same thing here, but what? Subtract 9, divide by 5, and you get 1 as another answer. I'm going to argue that if in fact we were to check this on the calculator, I'm going to plug it in, how about right here? Or you could even go all the way back to the beginning and prove it as well. But here is just as good because simply we subtracted 16. If you get negative 14, it works. If you don't, it doesn't, obviously. So if you plug in 1 is pretty painless to plug in without a calculator, actually. So 5 times 1, of course, that's 5. 5 plus 9 is 14. The absolute value of 14 is not negative 14. So b equals 1 is not a solution. Let's double check by plugging in the other value, negative 23/5. What is 5 times negative 23/5? Well, the 5's divide out, so you have negative 23 plus 9. What's negative 23 plus 9? Well, negative 14. The absolute value of negative 14 is positive 14, not negative 14. So this problem, of course, doesn't have a solution either with that one. So both solutions, because technically they're not going to check out, we say this problem overall has no solution. I would like you all to try number 8 as well as those problems on the prior page for extra practice.